Good morning, team. Today is Monday, May 4th, 2020, and today we're going to jump into some review of our Unit 8 materials. If you have not completed your Hello Morning survey, please pause and go complete that now. Thank you, team. Let's jump into our science and COVID-19 facts of the day. Today is super exciting because it involves scientists and engineers. So, the FDA has approved a new NASA ventilator for COVID-19 treatment. You may be wondering, what the heck is a ventilator? So, COVID 19 actually attacks the body's respiratory system, or the system that's responsible for breathing. It can lead to severe damage in the lungs, making it very difficult for infected individuals to breathe. A ventilator is a machine that is used for patients who need intensive treatment to continue breathing. And basically, what happens, as you can see in this demonstration, is that a tube is placed down a patient's throat, and then the ventilator actually manually inflates and deflates the lungs, which allows the lungs actually to repair. Okay, due to the number of infected individuals, there's a widespread shortage of ventilators right now, and they are also very, very expensive. So, NASA scientists and engineers actually built a ventilator which can be built faster and it's easier to maintain than traditional ventilators. And they did this in 27 days. So, we're going to check out this quick video.
We are designing an easy and rapidly mass manufacturable ventilator device, and it is a crazy project.
This crisis is unprecedented in our lives and requires precedented action.
I'm so amped up. I mean, it really, the adrenaline rush, it's exciting, but it's exhausting. I think we all just want to do everything we can to try to help.
Ready? Yeah. Oh, very cool. That's awesome.
I would say the biggest personal challenges that I have myself is I don't have time to sleep.
I think what JPL brings to the table is extraordinary talent. It also brings to the table tremendous innovation. The third thing it brings to the table is tremendous focus. The other thing that I felt, I see it in our team, and that is a call to duty. I have this talent. I'm an engineer or a scientist. I can do something.
We have the potential to save human lives, people that we might know, our neighbors, our families. And that intensity, amazing. It's amazing. And as stressful as this has been for everybody in the last couple of weeks, not one of us can stop.
Okay, so as you can see from my post, the FDA actually did approve that, which is super exciting. So my question for you today, now it's your turn. I want you to go to this post in Google Classroom and answer the question, why are the roles of scientists and engineers extremely important during this pandemic? So I want to know your thoughts. Why are the roles of scientists and engineers extremely important during this pandemic? You have 1 minute, go. Awesome, team. Now let's jump into our lesson for today. Today we're going to review some Unit 8 material. Our objective for today is that you're going to use the Ruby's test-taking strategy to solve problems related to interdependence among living systems. So let's go through some main ideas. Main idea number 1, vocab, vocab, vocab. There's lots of vocab in this unit. So let's make sure that you take some time to review your Unit 8 Quizlet, which is shared with you in Google Classroom. Main idea number 2, organisms and populations depend on and compete for biotic, which are living, and abiotic, which are non-living factors. So think water, light, food, space. Main idea number 3, short-term and long-term changes, for example, natural disasters and pollution, in the environment impact subsequent populations. Subsequent is like following, okay? Plants and animals adapt to these changes, and traits that are passed on from one generation to the next are affected by long-term changes. Main idea number 4, humans depend on ocean systems for many reasons, and our actions have drastically impacted these ecosystems. Now, let's review our Ruby strategy. First, we read and reread the question. Then we underline and understand what the question is asking us. We break it down, we identify the key concepts, and figure out what is this question asking me to do. Then we eliminate wrong answer choices and select the correct answer choice. Today we're actually going to use boxes, circles, and X's to follow our Ruby strategies because we can't show our work on paper. How are we going to do that? I'm going to show you how. So let's do an example together. Example number 1. A group of scientists studied some trees in a pine forest. In the densely forested areas, the trees were within 1 meter of each other. The scientists observed that these trees had dead branches near the ground. They measured the height above the ground at which the first living branches were found on different sized trees in the forest. Then they repeated this procedure on the same kind of trees in an open meadow. This graph right here summarizes the scientists' data. Which inference is best supported by these data? So we read the question. Now we're going to read it again and we're going to box our important information. Okay? So I can't underline right now, so I'm going to use these boxes instead. Oops. Okay, a group of scientists studied some trees in a pine forest. In the densely, I know that densely is important. Remember that this is a science term that means that things are really tightly packed together. So in the densely forested areas, the trees were within 1 meter of each other. The scientists observed, that means that they noticed, that these trees had dead branches near the ground. So this tells me that the dead branches near the ground are not getting one of the resources that they need, okay? Remember, these are tightly packed together, so they are competing with each other for resources like space, light, and nutrient soil, okay? They measured the height above the ground at which the first living branches were found on different sized trees forest. Then they repeated this procedure on the same kind of trees in an open meadow. So I know that this is important because in an open meadow, the trees are going to be farther apart. This graph summarizes their data, in which inference, this is my question, is best supported by this data. So an inference, remember, is like a conclusion. So we need to read through these answer choices and decide which conclusion is supported by this graph. So now let's look at our graph. Here we have the dense forest. These are the trees that are really close together. I see the short trees, the living branches start at about 1 meter and go up to about 3.5. The medium branches, the medium trees, the living branches start at about 4 and go up to 7. In the tall trees, the living branches start at about 6.5 and go up to 14. And then in the open meadow, the tall trees have living branches all the way from the bottom to the top. So there's definitely a difference here. So let's look at our answer choices. A, pine trees in a dense forest can grow taller than pine trees in an open meadow. So let's look at our graph. Here's the tall trees in the dense forest. Here's the tall trees in an open meadow. It looks like the height of these trees is the same. So I'm going to say that this is not correct. So is this correct? I'm going to say no. The height of the trees, of the tall trees in the dense forest is the same as the trees in the open meadow. So I know that this is not a correct answer choice, so I'm actually just going to move my X on top of this answer choice because I know that that's not correct. Let's look at letter B. Pine trees in a dense forest compete for sunlight with the surrounding trees. So here's the trees in a dense forest. If they're really close together and those trees at the bottom, or those branches near the bottom of the tree are dead, that tells me that they are competing for resources. So B could be my correct answer choice, but I'm going to look at the other choices just to be sure. C, pine trees in a dense forest, this is where they're tightly packed together, are part of a less complex food web than pine trees in an open meadow. So I know that pine trees, whether they're in a dense forest or in an open meadow, are going to be part of similar ecosystems. Also, this graph doesn't talk anything about the food webs of these places. So I know that this is not my correct answer choice. So I'm going to say no. The food webs of these trees would be similar and is not a topic of this graph. So I'm going to move another one of my X's on top of C because I know that that's not correct. D, pine trees in a dense forest have more living branches than pine trees in an open meadow. So here's my pine trees in a dense forest. Here are my trees in an open meadow. I know that this is not correct because the trees in the open meadow actually have more living branches than the trees in the dense forest. So is this correct? I'm going to say no. The trees in the open forest have more living branches than trees in the dense forest. So finally, I can move my X on top of D. Now let's go back and look at B again. Pine trees in a dense forest compete for sunlight with the surrounding trees. I know that this is correct because the branches near the bottom of the trees are dead, meaning they are not getting sunlight. So I can go ahead and put my circle around the correct answer choice. And now I'm done. So when I look at your work, I'm going to be looking for you to have boxed important information, for you to answer the question, is this correct, for all of the answer choices, to use your X's on the incorrect answer choices, and circle the correct answer choice. When I say go, you're going to, first of all, open the Unit 8 Quizlet. You're going to play a game to review your Unit 8 vocab terms. Then you're going to open the Google Slides and your Scholar materials, which will look like this. You have 4 questions that you need to complete. You're going to use your Ruby strategies to solve the practice problems using the boxes, circles, and X's to show your work, just like we did in the example. If you get stuck, use the links on the slide to help you learn more about that topic. So in your Scholar materials, slide 3 has a list of resources. There are videos and articles here to help you if you get stuck on some of the questions. When you're all done, you're going to turn it in Google Classroom. Of course, if you have any questions, email me or give me a call or text. Go. Thanks, team.